Today our topic is proof statements about segments and angles. So our learning target is how can I write proofs using geometric theorems? Proof. A proof is a logical argument that shows a statement is true. A two-column proof gives numbered statements and corresponding reasons that show an argument in a logical order. Reasons. The reasons that we can use in a proof. So reasons used in a proof can include definitions, properties, postulates, and theorems. Example 1. 4 steps of a proof are shown. Give the reasons for the last 2 steps. So we are given that AC is equal to AB plus AB. Prove that AB equals BC. So the first statement is always your given. So whatever you are given is always statement number 1. So right here we see it listed, AC is equal to AB plus AB. Given. Our second statement is that AB plus BC is equal to AC. That's by our segment addition postulate. Add the 2 pieces of a segment, you get the whole. Alright, so then we have AC and AC. We have 2 different things that AC are equal to. We can actually put those together based off of our transitive property of equality. Which is on your 2.5 resource sheet, transitive property of equality. So we have that crisscross piece happening. AC is equal to 2 different things. We can put the other 2 pieces together and state that AB plus AB is equal to AB plus BC. And then if we subtract an AB from both sides, so minus AB, we would be left with AB is equal to BC, and that is based off of our subtraction property of equality, which is also on your 2.5 resource sheet. Example 2. Using the theorems given to you, name the property illustrated by the statement. These theorems were given to you on your 2.6 resource sheet, so the resource sheet that you grabbed today along with your notes. So we have if angle R is congruent to angle T, and angle T is congruent to angle P, then angle R is congruent to angle P. So we have 2 things. So if we rewrite angle T is congruent to angle P, so this piece, we rewrite that underneath here, we have that crisscross piece happening. So whenever we see that crisscross, we can always set the other 2 congruent to each other, and so this is our transitive property of angle congruence. Second one, if segment NK is congruent to segment BD, then segment BD is congruent to segment NK. That's just flipping it around. So that's our symmetric property. And we're working with segment congruence, so we would say of segment congruence. And then lastly, segment CD is congruent to segment CD. That's just saying something is equal to itself or congruent to itself. So that is our reflexive property. And since we are working with segments, we would say of segment congruence. Alright, if you flip your note sheet over, we go to example 3, which says prove this property of midpoints. If you know that M is the midpoint of segment AB, prove that AB is 2 times AM and AM is 1/2 of AB. So we're given that M is the midpoint of AB. So we start right here with segment 1. M is the midpoint of AB. Always, that is your given. So number 1, given. Next we move to segment AM is congruent to segment MB. Well, we were told that this is the midpoint. So based off of the definition of midpoint, we can say that those two segments are congruent. So for number 2, our reason would be definition of midpoint. Then as we go down, we say that AM is equal to MB. We take away that congruence piece and we talk about the actual length of the segments. So that is the definition of congruent segments. So now that we stated that they are congruent, we can say that their lengths are equal. And then we say AM plus MB is equal to AB. Well, that's just saying that this piece here plus this piece here is equal to the whole piece, which we talked about earlier in this video, but that's our segment addition postulate. Which we learned about in Unit 1. All right, then we have AM plus AM equals AB. So we're really just taking this equation right here, but we're replacing that MB with AM because we know that they're equal. Right here we know they're equal, so we can make that substitution based off of our substitution property of equality. All right, and then the last piece, we have 2AM equals AB. Well, if we have AM plus AM, that's going to equal 2AM. So we say that that is our distributive property. And then lastly, we have AM is half of AB. So if we divided both sides by 2, we would get AM is half of AB. So that is our division property of equality. All right, last example here in our notes. We have example 4, shopping mall. Walking down a hallway at the mall, you notice the music store is halfway between the food court and the shoe store. The shoe store is halfway between the music store and the bookstore. Prove that the distance between the entrances of the food court and music store is the same as the distance between the entrances of the shoe store and the bookstore. All right, so first off, we need to draw and label a diagram. We need to make sense of the situation. So if you look here, we have the music store is halfway between the food court and the shoe store. So the music store is halfway between the food court and the shoe store. So that would be congruent segments because it's halfway. And then we have the shoe store is halfway between the music store and the bookstore. So right here, the shoe store is halfway between the music store and the bookstore. So these two segments would be congruent there. Prove that the distances between the entrances of the food court and the music store is the same as the distance between the entrances of the shoe store and the bookstore. So we want to prove that AB is congruent to CD. All right, that's what we want to prove. Draw a separate diagram to show mathematical relationships. So that's just saying we want to draw out that A, C, and then B in the middle. We have that congruent relationship there. And then we also have the congruent relationship between these two here. So it's just kind of separating them out, that they are congruent. Step 3, state what is given and what needs to be proved, then write a proof. Well, our given is what we just drew out. B is the midpoint of AC, and C is the midpoint of BD. We were given that in our information. It was halfway between. We want to prove that AB equals CD. So we want to write that in. our notes, and then we are going to write a 2-column proof to prove this fact. All right, so statement B is the midpoint of AC and C is the midpoint of BD. That is our given. That's what we're starting with. All right. Then we have definition of midpoint. So we want to talk about that congruence statement right here. We can say that segment AB is congruent to segment BC because that's the definition of your midpoint. Then we also have that segment BC is congruent to segment CD, which is also definition of midpoint. All right, if you notice we have that crisscross going on, that transitive property. So BC is congruent to both AB and CD. So then we can say that AB is congruent to CD. And then taking away that congruency piece and just talking about the segment's length, we can say that AB is then equal to CD by the definition of congruent segments. Alright, that's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.